I've given you a sheet now that tells you what calculations we need to be doing, okay? So the first thing that we have to do is figure out the actual concentration. Now you need to put into your data somewhere that the initial concentration of S2O8, 2 minus, and remember this little lower degree symbol, the S2O8, the initial concentration was 0.200 molar. The initial concentration of I minus, okay, is equal to 0.200 molar. But the initial concentration of the S2O3 is equal to 0.010 molar. So just under your data table or wherever, make sure you record this because that's going to be important. But that's what it was when it was just pure. But when we mixed it in the beaker, what happened to it? It goes down. It got diluted, right? What was the final volume for each of our trials? 10 milliliters of A, 10 milliliters of D, 5 milliliters of C, right? So it was always 25 milliliters was the final volume. Correct? So we need to get what the diluted, now when you go through trials 1 through 7, now obviously if you kept it 10 for the first 4 trials, you don't have to do the concentration 4 times. We just need to figure what it out. Now, when you do a dilution problem, does anybody remember the equation? M1, but we'll say molarity of the concentrated times the volume of the concentrated, that's M1D1, is equal to molarity of the dilute times the volume of the dilute. Now we need the molarity of the dilute. We know this. The concentrated are these. Okay? So we know then to get the molarity of the dilute, we just divide by the volume here. So this is really the net result times volume of concentrated over the volume of the dilute, the total volume. What did you start with versus what's the final volume? The volume of the dilute. That was 25. Okay? So for trial 1, S2O8 2 minus, how many milliliters did we use? 10 milliliters, right? So in order to calculate the diluted concentration, we're just simply going to take the 0.2 molar times 10 milliliters divided by 25 milliliters. Because it's 10/25 is concentrated once we put it into the beaker, right? So the actual concentration of the S2O8 when it was reacting was less than this. So if you take, this is going to come out to what, 0.4? 0.04, I mean? What does that come out to? 0.08? So this is my initial concentration of the S2O8. Okay, that's what I really was my initial concentration. I started with this in the bottle, but when I actually reacted it, it was this. So you need to do this now for the S2O8. For the S2O8A, that was the, so this is 1, and it's 10 milliliters. You're going to have the exact same calculation for I minus. Okay, so you're going to have 4 calculations for I minus, 4 calculations for S2O8. 10 milliliters, 8 milliliters, 6 milliliters, 4 milliliters. So instead of saying 10 divided by 25 for the next one, for D, you'd use 8 over 25. We don't care about B. B was just spectator ions. And then 6 over 25, and then 4 over 25. Then you do the exact same thing for the I minus. You started with 10. That's trial 1. And then for trial 5, you had 8. trial 6, you had 6, and for trial 7, you had 4. Okay, so you have 8 times. So let's go ahead and do that right now in your calculations, and you can label this concentration of dilute solutions, and then just label it. Point the camera over here. So you're going to say S2O8 2 minus. Okay, so you're going to say trial 1. Trial 1, we're going to go 0.02, 0.2 times 10 over 25 is equal to, and we got 0.080 molar. Now, S2O8, this is A. We didn't change that on 2, 3, or 4. But in trial 5, 0.2 molar. What ratio are we gonna use? 8 over 25. That's gonna give you something. Then for 6 and 7, do the same thing. Then make another column where we're gonna do I minus. You're gonna do the exact same thing, except it's gonna be 1, 2, 3, 4. We all good? You understand what you're supposed to do? You got them all? Okay. You don't need to get me drinking. So Carrie, you know what you're doing though, right? Okay, so just take a pause on that, and then you'll have time to go finish this. Now, we want to calculate the actual rate. The goal is to calculate the rate. The rate is always the change in concentration of the S2O8 divided by the change in time. We measured the time. We know these values for 1 through 7. We just need to know how much did the S2O8 actually change. Well, that's where we're using this, my limiting reactant. So we need to figure out how many moles of this reacted, and again, I forgot my 2, okay? We need to know how many moles of this reacted, and then we know for every 1 mole of iodine, which got made, 1 mole of S2O8 disappeared, got used up. So it's really a 2-to-1 ratio. For every 2 of these that got used up, only 1 of those got used up. And so you can kind of see the relative rate law on the calculations page that I gave to you, that the rate of this is going to be 1/2 the rate of that. Okay? So we need to figure out how many moles are being lost here. Okay? So how do I figure out, if I know that how much of this did I use each trial? 5 milliliters. Okay? So I had 0.00500 liters of S2O3 2-. That's how much I started with. Now I know that the concentration of this was 0.010 moles per liter. Therefore, this is 5 times 10 to the minus third. I'm going to be at 5 times 10 to the minus 5, right, moles. Moles of S2O3. That's how much reacted. Okay? So if I have 5.00 times 10 to the minus 5 moles, okay, how many moles of S2O8 reacted?
10.
2.5, right? Because it's 1/2. Over 2 moles S2O3. Okay? So this means 2.5 times 10 to the minus 5th moles reacted of the S2O8. Now let's just go ahead and put S2O8 on there. Okay? But the rate is moles per liter per second. So how many liters was this in? What was our total volume? 25 milliliters again. So the change in the molarity is equal to 2.5 times 10 to the minus 5 moles divided by 0.025 liters. And that comes out to 0.010, I believe. Comes out to 0.0010.
Yeah, it's 0.0010.
Yeah, 20. This is equal to my change in the S2O8. Okay? That's my change here. Because every time we put 5 milliliters in, it was the same concentration every time, diluted to 25, and so, and we could have diluted it up here. We could have said to get the initial concentration and just divided by the 25 here, and then done the molarity at the same time. It doesn't matter when you divide by the 25. Okay. So That's my change. So now I know my rate is always going to be 0.0010 divided by the time of each trial. So this is my change in concentration for every reaction. So now you have to go through and calculate the rate for all 7 reactions, which is simply going to take 0.0010 divided by the time for each one. That's number 2 on your calculations page. Do y'all understand the math that I just did?
Little.
Found out how many moles, but molarity times volume equals moles. Then I just used the mole ratio, it's 1 to 2, to figure out how many moles of S2O8 reacted, and then I divided that by the total volume it was in, 25 milliliters.
And that's how much was used.
And that's got how that's the change during that amount of time. That was the change in the concentration of the S2O8.
Okay.
So in other words, only a very small fraction of the S2O8 actually reacted.
Is it supposed to be negative?
Yes. And what's the negative sign tell you on rate? It's getting used, it's disappearing versus appearing. So the sign's not all that important. Most of the time what you'll do is you just, in the title, you'll say rate of disappearance, and then you can put everything in terms of the positive. So you do need to have this on how we're getting that. So this calculation needs to be in there.
And then the unit is molarity per second.
Yes, molarity per second. Now this is what you're really gonna love, is that once you get those 7 rates, then you look at number 3 on the calculations page, that chart. You need to copy that chart and recreate that chart in your lab manual.
Hooray, woo.
Because what we're doing is we're making a differential rate law, we're making experimental data with changing concentration, change in rate. Just like all the practice problems we've been doing. We're making our own chart.
Cool.
Now, once you get that chart made, then you can do just like this practice problems, you can figure out what X and Y are by looking at the change in concentration versus the change in rate. Okay, so we want the order of the reaction with respect to S2O8. Show your math, S2 according to I minus, the overall order, then write the rate law, all for 4. Then you have to calculate K for every reaction, all 7, and then get the average, and then answer number 6 question, okay? So that's all the calculations. This is the hard part right here. Now you just fill in the chart. Once you have the chart, it should be just like all the other problems. And then you figure out what X and what Y are, what's the order of the reaction, figure out the value of K. Yes, it's tedious, you have to do it 7 times. But once you get that, then get the average, and then just answer question number 6. Okay, so that's all you have to do.